In this lesson, we will explore concepts for how to manipulate lists and nested lists in Dynamo. By the end of this lesson, you'll have an understanding of what a nested list is and how to obtain items within a nested list. In order to get started for this lesson, we're going to open the sample file from the previous lesson titled Data Management. As a reminder, the lesson files are available in the link on dynamobim.org/learn. Alright, with this file opened, it may open in manual run mode. As a reminder, the run mode is located in the bottom left-hand corner of the Dynamo user interface. Let's go ahead and switch this to automatic for the rest of this lesson. As you may remember, this graph is creating a number sequence that is being fed into a point by coordinates node. Within the point by coordinates node, we have the lacing set to cross product to create a grid of points. Let's go ahead and add a watch node. We can add a watch node by right-click searching for the node watch. We'll drag this to the right, and we'll make sure we connect the output. We can go ahead and resize this watch node as well. Watch nodes are really great for visualizing data within Dynamo. Considering this graph already has points created, we can of course navigate the background preview by selecting the Enable Background 3D Preview icon and zooming around. Right-clicking will allow us to pan, orbit, and zoom. Within a watch node, we can select individual objects to get a preview of them in the background 3D preview. For instance, if I select the point at index 0, 0, we will see that get highlighted. Selecting more points will enable us to preview what their location is as well. This is the concept of a nested list within Dynamo. In order to retrieve specific points within the watch node, we can use a node called getItemAtIndex. Let's go ahead and search for that node now. In our node library, we'll search for getItem, and it should be the only result to show up, getItemAtIndex. We'll place this node now. The input port for this node takes a list input. This can represent a flat list or a list with several different sublists similar to what we have above. The second input is an index, which is an integer or whole number that represents the list index that you want to retrieve. In order to visualize this, we're going to use an integer slider in order to select our index. Let's search for that node now, and we'll select integer slider. By default, our integer slider has a range of 0 to 100 at a step of 1. We'll leave that for now. This will go into our index input for our getItemAtIndex, and we will go ahead and use the output of our point by coordinates node for this process. At this point, since we are on run automatic, we will notice that we do have points being retrieved. Our background preview doesn't really show us the whole picture at this point, so we need to hide a few things. In Dynamo, geometry previews are rendered for each node that has a preview available to it. In order to better isolate what we're currently doing, we can go ahead and navigate to our point by coordinates node, right-click on it, and select the preview icon. This results in a new icon that indicates that the geometry has been hidden in the background preview. It also includes a gray bar along the bottom of the node. Now, the background preview that we're seeing is representative of the getItemAtIndex node. Selecting the getItemAtIndex node will highlight those geometry elements blue. Holding down Escape, we can zoom in to better see these results. Now, since we are on run automatic, if we drag our integer slider around, we will see those values update dynamically. These values represent the index of the list that we are retrieving. In this case, our list is our grid of points, and each sublist represents a column of points. Within our watch node, we can observe what the maximum index is that we have in our list. At this point, the maximum index is 19. So if we were to drag our slider to a value that's larger than our input list, we will receive an error. In order to fix this for this example, we can go ahead and change our integer slider to have a maximum value of 19 and a minimum value of 0 with a step value of 1. This enables us to control this interaction in a more specific way. And now as we slide our slider, we won't receive an error state for the getItemAtIndex node. Let's say that I want to retrieve an individual point within the sublist. How would I do that? The easiest way to do this at this point would be to use another getItemAtIndex node. In order to do this, let's go ahead and hold down the Control key on our keyboard and make a copy of this getItemAtIndex node. In my case, I'm going to replace the output to the input of the list on the new getItemAtIndex. We'll disable this preview and we'll zoom around so that way we can see the results a little bit better. In addition to the getItemAtIndex, we're going to copy the integer slider node, and we'll replace the input of index with this new integer slider. Now we can make changes to the second integer slider, and we will see that getItemAtIndex update. However, we still see the full column of points at this time. In order to isolate this new getItemAtIndex node, we'll right-click on the previous one and deselect the preview. And now as we change the slider, we will see different points begin to be isolated. So now we're really traveling down into those nested lists to figure out what we're producing. Let's add something to better visualize this point within the whole grid of points. We can go ahead and add a circle around the point to better highlight it. Within our library, if we navigate to Geometry, Curves, Circle, we have an option to create a circle by center point and radius. Let's go ahead and place this node now. For our center point, we will use our individually selected point. For our radius, it does have a default value. Once again, selecting geometry in the node workspace and navigating to the background preview, we are able to zoom in on that geometry. We'll click outside. We'll navigate back to the node view. At this point, we are highlighting the point that we're selecting from our getItemAtIndex node. Let's go ahead and zoom back out and toggle the previous grid of points geometry back on. We'll right-click on the point by coordinates node, the initial one, and we will toggle the preview back on. While holding down escape, we can zoom out to see what's going on. In this case, our circle by center point radius is a really small radius, so what we're going to go ahead and do is we will right-click and search for another slider node. We'll use a number slider, and we'll plug this into our radius, and we'll make it a size that's easier to see. For my value, I ended up using a value around 30. You can use whatever value you'd like, as long as you can see it. Now as we make changes to our getItemAtIndex nodes, we will see which points we are starting to select. We are now starting to highlight which sub-item we are selecting from the overall list of sublists. Next, let's explore list interactions. One thing Dynamo is very good at is counting. There is a whole category of nodes dedicated to modifying and working with lists. We navigate to List, Inspect. We have a whole lot of options in here to interact with lists. In our case, we can count lists as well, or items within the list. I'm going to place the count node now. Connecting our watch node to our list count node, we are able to see that we have 20 items. This represents the overall amount of lists we have within this overall list. As a reminder, Dynamo starts counting at 0, so that's why we see a value of 19, but a count of 20. And why is it starting to count 20 at this time when there are several sublists within this overall list? In Dynamo, with sublists, we have these levels assigned to them. By default, the list count node is using the outermost list to figure out the count. At this point, that level is level 3. In Dynamo, if we want to navigate down the list into sublevels, we can do that. The easiest way to do this is to click the chevron icon on the input port and navigate to Use Levels. This now results in us using the level 2 level to count the sublists count. So as you can see, we now have 20 sublists of 20 items available to us. Whenever you select Use Levels, you are offered another interaction to where you can change this level really quickly within Dynamo. Clicking the up and down arrows will change the level at which it's working at. For instance, at level 1 counts each item individually. Not really helpful, but it ends up giving us the number 1 for every single item in the list. Level 2 gives us the count of the sublists, and level 3 gives us the number of sublists in the overall list. With that in mind, you should have a better understanding of sublists. In Dynamo, working with lists is something that you are going to do every time you're in Dynamo, so it's one of those things that takes practice. Working with the level option and the get item nodes, we are able to quickly interrogate lists to work with them. In our next example, we're going to explore this further by adding computational logic to this grid of points. So to review, in this lesson, you learned how to use the list at level command, and you learned how to work with sublists with get item at index nodes. I encourage you to check out the next lesson where we add computational logic to this graph and we explore these list interactions further.